Good morning, AOBI. This is Mr. Dunning. Stand by. I have a math lesson for you. Let's take a look now at how this algebra of circles plays out when we're looking to find pairs of points on a circle. If we know that point is on the circle, then we know the distance over and the distance up. That tells us that there's a companion point or a pair down here. The same distance over and the same distance down. But we're not done, because there's a companion point over here too. Then again, will be the same distance over and the same distance up. But we're still not done. There's a companion point down here. That will be the same distance over and the same distance down. So if we know one point on a circle, we actually know 4 points on the circle. Now this problem is easy when the origin is at 0, 0. Let's do a couple of examples so that you can see just how easy this is when the circle is centered at the origin. In example 1, we have a circle, radius 5, centered at the origin. And I've depicted 2 points, one in red and one in green. Let's look at this point here. The point is 3 over and 4 up. Just looking at that one point, I know that there's going to be another point down here, 3 over and 4 down. And I know there's going to be a point over here, 3 over and 4 up. And last, I know there's going to be a point down here. That's 3 over and 4 down. Now let's look at the green point. The green point is 4 over and 3 up. As soon as I know that, I know that there will be a pair of points down here, 4 over and 3 down, 4 over and 3 up, 4 over and 3 down. Finding pairs of points on a circle centered at the origin is really pretty easy. But it's almost as easy if the center isn't at the origin. Let's do one more example here with a different circle and see how you do with that. In example 2, we have a circle centered at the origin with a radius of 4. Now this is going to be a little bit more difficult, so I'm going to put the equation here. The equation of this circle, x squared plus y squared, is 16. The radius is 4. 4 squared is 16. So if I know that there's a point 3 over, I need to put the 3 in for x right here. 3 squared is 9. When I subtract 9 from both sides, y squared is 7. Y will be the square root of 7. Now, don't get all upset. The square root of 7 is a number, okay? It's bigger than 2 because 2 squared is 4, and smaller than 3 because 3 squared is 9, but the square root of 7 is just a number, that's all. And this point, 3 over square root of 7 up. See? A number bigger than 2 and smaller than 3. Piece of cake. Now, the pairs of points. There's going to be one down here. 3 over and minus the square root of 7 down. There'll be one over here that will be 3 to the left, and the square root of 7 up. And there'll be one down here that will be 3 over to the left, and the square root of 7 down. So we're still using the idea here, pairs of points. And if you know one, you can find the other 3. Piece of cake. Let's do one more example. Still working with a circle centered at the origin. In example 3, we have a circle centered at the origin, radius 3. So as soon as we know the radius, we can put this in. That'll be 3 squared, or 9. All we need is one point with either an x value or a y value. This point is some distance over and 2 up. So we have to put the 2 in where the y is because that's our distance up. Let's do that. X squared plus 4 is 2 squared, is 9. Subtract 4 from both sides. X squared is 5. X is square root of 5. Now, again, don't let these radicals or square roots frighten you off. Square root of 5 is just a number. It's bigger than 2 because 2 squared is 4, and it's smaller than 3 because 3 squared is 9. But the square root of 5 is just a number. That's it. So I know that it goes here. So this point is the square root of 5 over and 2 up. Square root of 5 is a number bigger than 2 and smaller than 3. Easy peasy. Companion point down here, a pair, is also going to be the square root of 5 over but it's going to be 2 down. The companion point over here is going to be the square root of 5 left and 2 up. And the companion point down here will be the square root of 5 over left and 2 down. It's really easy to find these companion points working off the basic equation. Our next stop is to work off a circle not centered at the origin. And we're going to have to think through that. We'll do a couple of examples, and then we'll give you a problem for you to do at home. In example 4, we have a circle, but it's not centered at the origin. The same drawing that we did over here applies just like it did in the first 3 examples, but we're going to have to adjust where we put X. The center of the circle is 3 over and 3 up. So those 3's go right there in the equation. The radius is 3, squared is 9, and that is the equation of this circle. Now, if I have a point here 2 over, I want to know how far up it is. But wait a second. It can't be 2 over and be there, because 2 over would be over here. So put on your thinking cap. It's 2 from the center, but the center is 3 over. Got that? This point is 2 from the center, but the center is 3 over, so the x-coordinate here would be 5, not 2. All right, still got your thinking cap on? I know the distance from the center is 2. And for a moment, I am going to just use that, okay? To give me this. You're saying, well, wait, what? X is 5. Yes, X is 5. That's a 5 there. That's why the X value is 5. 5 minus 3 is 2. Squared is 4. And now we've got this y minus 3 quantity squared, and that's still equal to 9. Subtract 4 from both sides, and we have y minus 3 squared is 5. And at this point, we've just taken a flying leap out of geometry right into the lap of algebra, because now we have to solve this little puppy, okay? Let's see how we do about that. If I have a square here, I can undo that with a square root. So that's what I'm going to do. My next step is going to be to take the square root of both sides. When I do that, on this side I have just y minus 3 is the square root of 5. Then in my last step, I'm going to add 3 to both sides, telling me the y value here is 3 plus the square root of 5. Got that? That would be the y coordinate there. Now, if you're thinking, God, I hope you're thinking, you're saying, well, wait a minute. The square root of 5 is a number bigger than 2 and smaller than 3, so the y value here is going to be bigger than 5. Well, yeah, because we began at a y value in the center of 3. So that is correct, and I'm glad you were thinking. Now, the companion values, they should be easy. We have one down here, 5 over, and the negative of this. We have one over here. Okay. Now wait a second. We only went 2 this way, so this coordinate is not hard to figure out. It's 3 minus 2, or 1, and the y coordinate is still 3 plus square root of 5. And down here, we have a companion point that is also 1 over and minus 3 minus square root of 5 down. Numbers look a little different, don't they? But the computation is the same. Now let's review. We had to account for this 3. So when we went 2 over, okay, we didn't get to 2. Come on, you nummies. We went to 2 plus 3. And that shows up here when we put in that 5. Because it says we went 2 over from the center at 3. We'll do one more of these. These are a bit more challenging, but not much. It just takes you deeper into algebra. And that's what we're doing, the algebra of circles. In example 5, we have a circle centered 4 units over and 3 units up. So we can fill in those numbers here. The radius is 2, squared is 4, so this is the equation of that circle. Now, we have a point that's 3 units over on the x-axis. So, we put that in. Don't be shy. Plug it in. When we plug that x value of 3 in here, we get -1 squared plus the quantity y minus 3 squared is 4. Well, -1 times itself is 1. Subtracting 1 from both sides of the equation, we get y minus 3 squared is 3. Taking the square root, that's how we undo a square, we take a square root. We get y minus 3 is the square root of 3. So our y value is going to be 3 plus the square root of 3 because we're going to add 3 to both sides. Y is 3 plus radical 3. You're saying, well, wait a minute, that doesn't look right. Radical 3 is a number bigger than 1. It's not as big as 2, but it's bigger than 1. So that number is going to be bigger than 4. What's going on here? Well, it's really simple. When we do a square root, it has both a plus and a minus. That is, the square root of 3 could be plus the square root of 3 or minus the square root of 3. And the one that makes sense here is minus. Because this point is, in fact, about 1 less, in fact, a little bit more than 1 less than 3. And now, with this, we could do all 3 companion points. These problems are a little bit more difficult and they call for a knowledge of numbers and algebra. Tomorrow, we're going to attack what happens when we expand these algebra expressions. And you'll learn to recognize the equation of a circle when it's in an expanded form. Meanwhile, you've been a fantastic audience. Have a great night. I'll see you tomorrow.